In these examples, let's write down trigonometrical ratios according to the angles labeled in right-angled triangles. In example 1, there is the triangle ABC. We all know the side lengths and labeled angle is A. And according to the angle A, let's identify hypotenuse, adjacent side and opposite side. Hypotenuse is always the opposite side of the 90 degrees, so it is the side AB, and the length of the hypotenuse is 5. The opposite side of the angle A is BC, and the side length of this opposite is 3. The adjacent side is placed next to the angle A, and it is 4 in length. So, trigonometrical ratios are given next to the page. So you see SOH represents sine, which is opposite over hypotenuse, and opposite side length is 3, hypotenuse side length is 5, so 3 over 5 is the ratio of sine of A. Then cosine of A is adjacent over hypotenuse, and adjacent side length is 4, hypotenuse is 5, so 4 over 5. Tangent A is opposite over adjacent, so opposite side length is 3 and adjacent side length is 4. We finish with example 1. In example 2, we have another triangle DEF, and F is the labeled angle. Let's identify the hypotenuse, opposite and adjacent sides. Hypotenuse is opposite of 90 degrees, and the side length of hypotenuse is 13. The opposite is the side ED, which has the side length 12, and adjacent of angle F is the side DF. It is 5 in length. So sine of F is opposite over hypotenuse, which is 12 over 13, and cosine of F is adjacent over hypotenuse, which is 5 over 13, and tangent of F is opposite over adjacent, which is 12 over 5. In this given right-angled triangle, let's find which trigonometrical functions represent these ratios. Ratios are given next to the triangle, and according to the 70 degrees we have ratios, and according to the 20 degrees we have ratios. So in the triangle, according to the place of 70 degrees, I'm going to label hypotenuse, adjacent and opposite sides. So hypotenuse is always the opposite of 90 degrees, and this is here. The letter C represents hypotenuse. According to the place of 70, the opposite side is B, and adjacent is A. Then, somewhere here, let's write SOHGÜR in order to remember the formulas easily. So, in the first ratio, A represents adjacent and C represents hypotenuse. So, adjacent and hypotenuse is used together in the cosine. So, this is cos. In the second one, B is opposite side and C is the hypotenuse. Opposite and hypotenuse together is used in the sine. So this is sine. and B opposite. A represents adjacent side, and opposite and adjacent together is used in tangent. So this is tan. I'm going to do the same steps for the angle 20. I used pink color. Follow the pink color now. According to the 20 degrees, I'm going to label the side lengths. Which one is hypotenuse? Always the opposite of 90 degrees is hypotenuse. So C is hypotenuse again. And according to the 20, the adjacent side is going to be B. So I change it. This is adjacent side. And the opposite of 20 is here. Okay, I go to the ratios. So according to the 20, A is opposite, C is hypotenuse. So opposite and hypotenuse together used in sine. B is adjacent, C is hypotenuse. So adjacent and hypotenuse together used in cosine. And A is opposite, B is adjacent. Opposite and adjacent is used in tangent. So have you seen some of the ratios are equal? So here we have A over C and A over C, B over C and B over C. And we see that cosine of 70 degrees equals sine of 20 degrees. And sine of 70 degrees equals cosine of 20 degrees. Have you realized the relationship between 70 and 20? So 70 and 20 together makes 90 degrees. And we can say that if we have two angles, let's say A and B, have a total of 90 degrees, sine of A equals cosine of B, and cosine of A always equal to sine of B.